This is 337 representing sound. We've got here table 1 shows 4 stages in converting sound into a digital form. Show the correct order for the stages by labelling them with numbers 1 to 4, 1 being the first stage. So we need to have a really good look at these 4 stages here. So binary representation of level stored, well, that's going to be the final one, I would have thought. So I'm just going to put here 4 question mark just for later. Microphone picks up sound wave. That, I would imagine, is going to be our first one, because you're going to have to pick up the sound before you can do anything else. Then we've got value read at specific point and rounded to a level. Well, that could possibly be the second one, but let's just have a look here. Converted to an electrical analog signal. I think that's more likely to be the second one, which would mean that one would be the third one. So let's just step this through then. So the microphone picks up sound waves. It's then converted to an electrical analog signal. Yeah. The value is read at a specific point and rounded to a level. Yeah. And then binary representation. Yeah, I'm happy with that answer. So I'm going to write it in now. So I've got 1, 2, 3 and 4. Then it says calculate the file size in bits for a 2-minute sound recording that has used a sample rate of 1000 Hertz and a sample resolution of 5 bits. You should show your working. So it's 2 minutes, it's 1000 Hertz and it's 5 bits. So they're the 3 key bits of information that I need to answer this question. So it is Hertz times the bits times the number of seconds, because Hertz measures the number of samples per second. So we want to make sure that we're doing 2 times 60 here to work out the seconds. So Hertz is 1000, bits is 5, and 2 times 60 is 120. So 1000 times 5 is 5000, and timesing that by 120, if I times it by 12 first, then that's going to make the maths a little bit easier. So what is 5 times 12 first of all? What's 5 times 12? 60. Just ask my 9-year-old son there what 5 times 12 was. So it's 60. Okay. So we know that 5 times 12 is 60, and then we've got all these zeros left. And that gives us the answer. So the separator just needs to be moved along now to there. So it's 600,000 bits. So one way of representing sound digitally is to take samples of the original sound. Define sampling rate. So sampling rate is how many samples are taken per second. So sample rate is how many samples are taken per second, and then this is measured in Hertz. The reason I added that extra bit at the bottom was because the question is worth 2 marks, so just putting sample rate is how many samples are taken per second is not going to give me 2 marks. It's looking for an extra point there. So I'm adding on it's measured in Hertz because that's an extra bit of information that will get me a second mark. Now we've got to calculate the storage requirements that will be needed to store sound samples. You need to know both the sampling rate that will be used and the sampling resolution that will be used. Explain how to calculate the storage requirements for the sampled sound data. So this is worth 2 marks as well, and it's an explain. So we're going to have to put 2 points and explain it well. So we've got, let's just read the question again. Need to know sampling rate and the sampling resolution. Now it's left out a key piece of information there, which is how long the sound is as well. So we would also need to know the length of the sound, then we would calculate sample rate or hertz times sample resolution in bits times length in seconds. So that is going to be 60 times minutes.